I'm Diana, thanks for having me out, really appreciate it. So my project is quite similar to John's, so you guys might see some similarity. The major difference is that mine uses photography. So I use time-lapse photography to capture skiers on Saddle Peak as a method of tracking backcountry skier terrain preferences. So basically my research was motivated to better understand how backcountry skiers negotiate avalanche terrain. If we can better understand how people perceive the avalanche problem, maybe we can better understand how they respond to an avalanche forecast. So basically, how do skiers move through backcountry avalanche terrain? Can we create a method to capture an unbiased group of skiers? So can I get everybody on Saddle Peak instead of just a couple of volunteers? And what do we see? Do their terrain choices actually vary with different forecasted avalanche conditions? So in order to do this, I needed high-use uncontrolled avalanche terrain. I needed an ideal location to put up a time-lapse camera and hopefully a slope with a good history of avalanche activity. And we have Saddle Peak, so that's where we went. So for those of you that don't know about Saddle Peak, we'll just touch on it really quick. Saddle Peak's adjacent to the Bridgeable ski area. People generally ski the football field, and then we also have the North Bowl, which is directly fall line from Saddle Peak. And then I did a little bit of research just to see the area, so I got a little bit of information on South Peak just wrapped around the corner there. But it's big avalanche terrain, cliffs in the middle, complex start zones, wind loading, basal depth hoar, all sorts of fun stuff. So with the help of Bridgeable Ski Patrol, we installed a Canon digital SLR camera on an unused gun platform within the Bridgeable ski area and programmed it to take one photo every 10 seconds between 10 a.m. and 4 p.m. Operation hours. So the study area is identified in the red dashed line, and this is kind of what we see. So we can identify skiers, but we can't tell who they are. We can't even tell if they're wearing a backpack. They're just little dots moving across a slope. Another photo just looking northwards from Saddle towards the Bridgeable ski area. And yeah, it's a popular place to ski. Multiple groups hiking the ridge and skiers simultaneously on slope is a common sight. And we also do manage to produce a couple of avalanches every winter. So as John touched on, one of the more memorable events in Saddle Peak history was February 2010. After a 30-inch storm and strong winds, a chunk of cornice was cut from the ridgetop, rolled down slope about 100 feet, and initiated a rather large avalanche, approximately 1,000 feet wide, 4 to 6 foot crown, and 2,000 feet long. So at the time, it's estimated that 20 to 30 people were hiking the ridge, and several had already skied the slope. It was caught by several people as well as witnessed from the ski area. The photo on the top left is from the chairlift. So the avalanche was captured, and there could have been many people involved, but fortunately there wasn't. But it does highlight the potential for a pretty catastrophic event. So between 2010 and the end of last season, I found photographic documentation of 11 different avalanche events around the Saddle Peak area. And notably, Saddle Peak's South Bowl seems to produce avalanches every season. So these are crown lines for the events involving people, and I'll just go over a quick summary of those. So February 2012, a skier triggered an avalanche in Saddle Peak's South Bowl. The skier was carried 2,000 feet down slope, partially buried and injured. 2 days later, the North Bowl of Saddle Peak avalanched naturally. The crown was 3 to 5 feet deep and propagated a few hundred feet across the slope. In December of 2013, the football field was triggered by Ski Patrol, who reported a failure deep within the snowpack. Then in January 2014, the football field ran again, this time sympathetically to inbounds control operations. In mid-December 15, several natural avalanches were observed in the Bridger Range, and the football field was intentionally triggered by Ski Patrol. It ran 100 feet wide, 4 feet deep, and failed on basal facets. A month later, in January of 2016, the football field was triggered by skiing public. The avalanche was 200 feet wide with a 2-foot crown and ran 1,500 feet. It was a close call, but fortunately nobody was involved. And this is just with the December event and the crown with it. And this was the first season that I had the camera up, and we actually captured the January 2016 event. And I'll come back to that later for those who haven't seen the video. But as we know, Saddle Peak has some great terrain for us to watch people ski on. So essentially, I put up a camera and watch people ski Saddle Peak. So I'm going to show you just kind of what I captured. Sunday, February 14th, mostly sunny Sunday.
To decide that the things that I tried were in my life just to get high on. When I sit alone, come get a little known, but I need more than myself this time. Step from the road to the sea to the sky, and I do believe that we rely on. When I lay it on, come get to play it on, all my life to sacrifice. Hey, oh, listen what I say, oh, I got your head. Now listen what I say, oh, oh. When will I know that I really can go to the well one small time to decide on? When it's killing me, when will I really see all that I need to look inside? Come to believe that I better not leave before I get my chance to ride. When it's killing me, what do I really need? All that I need to look inside. Hey, oh, listen what I say. Come back and hey, oh, look at what I say, oh. The more I see, the less I know, the more I like to let it go. Hey, oh, whoa, whoa.
Is that video real time?
So it was just a selection of kind of my favorites of that day, and so the images at the bottom, there's a timestamp and an image number, and that'll kind of give you more idea of where things are, but yeah, I condensed it for sure. It's on YouTube as well if you'd like to watch it again.
Sometimes, you know, there were 3 or 4 dots at the same time.
Yeah, so those, as long as the lines were happening together, those skiers were skiing together, is kind of how I did it. So now that I have all these skier points, I need to digitize them in order to get some information off them. So to do this, to study the 10-second terrain preferences of these backcountry skiers on Saddle Peak, the images were digitized and then referenced within a coordinate system. So from the oblique photos, we digitized the skier points, and then the red circles are ground control points. So I identified ground control points in both the oblique photo that the camera took and the DEM, which John touched on, how we got our DEM. Once I had those ground control points, I used a transformation process on my digitized skier points in the oblique photo to move them onto the DEM, so then I could pull terrain metrics from that DEM, apply them to the skier points, and basically give those individual skier points a location in space and time so that we could analyze them. So, for the analysis of skier terrain preferences, I got 13 days on Saddle Peak over 2 winter seasons, and documented 525 skiers and just under 7,500 skier points. So on 4 days of low avalanche hazard, I had 182 skiers. On 4 days of moderate hazard, I had 175 skiers. And on 5 days of considerable hazard, I got 168 skiers on Saddle Peak. Similar to John, I looked at the same terrain metrics, so slope, downslope curvature, which is that convexity concavity, and cross-slope curvature. So are we on a ridge top or in a gully feature? So for example, this is Saddle Peak, Google Earth image. And from our oblique photos and transformation, we can identify skier tracks and then use the digital elevation model to identify slope angles for the terrain. So red would be very steep, green would be your mellower terrain, and then the black lines are skier tracks. So here we look at the slope angle. The oblique photograph with the red dots is georeferenced to the DEM. The DEM is the grayscale background with the colored dots, and those dots represent slope steepness. So this image gives us the slope for every skier point on February 14th, 2016, with an average slope angle skied of 26 degrees. So these are the results. Analysis on terrain metrics of skier point locations indicated that the terrain preferences on considerable hazard days were statistically different than moderate and low hazard days. We didn't have any higher extreme days, so that's what we looked at. So slope angles skied on considerable hazard days were less steep than moderate and low days. Downslope curvature analysis suggested that skiers chose more supported or concave terrain on considerable days than moderate days. And the spread of the data indicated that skiers kind of chose planar, so neither ridge features or gully features on considerable hazard days. They were more inclined to find ridges and gullies on those lower hazard days. So one notable observation we had was the large number of solo skiers on Saddle Peak, and maybe this can kind of join in with Carl's talk. But out of 525 skiers captured on Saddle Peak, 94 or 20% were in a group, 18%, just under 20. And then if we look at groups, so basically this is a really subjective process. I looked at the pictures of people skiing that day, and if there were indications that these people belonged to a group, I put them in a group. If, for example, there's a whole bunch of people at the top of the mountain, one guy took off the other way and never met up with anybody else, that was a solo skier. So I think most of us could agree on our group sizes, but I also looked at the groups. So out of 255 groups of skiers, 94 of those groups, or almost 40%, are solo groups. And it's notable that almost 1 out of every 5 skiers on Saddle Peak is without a partner, and 2 out of every 5 groups is a solo group skier. Most interesting is the top, this guy right here. So on considerable hazard days, we had 33% of all those skiers, 33%, 56 out of 168 skiers were solo on Saddle Peak on considerable days. And it was significantly higher than those kind of other days as well as the average. So that's a little bit of the data I'm getting from this and working through. And then back to that event we talked about earlier. So January 14th, 2016, this was the first season the camera was up. And a couple skiers remote triggered an avalanche on the football field. So I'm going to just kind of go through a quick video. It's a summary of a larger video that's also on YouTube if you're interested, but it just shows the skiers and the avalanche event about an hour prior to the avalanche and go from there. So January 14th, 2016, Bridger Range got 4 to 6 inches of new snow overnight, 2 to 3 inches forecasted for the day. Avalanche hazard was considerable on all wind-loaded slopes, and the primary avalanche concern was wind slab on basal, depth floor, and facets. Late in the morning, an avalanche on the football field was triggered by skiers, and the event was captured by the camera. So we'll run through the event starting about an hour prior before. At 10:47 a.m., the first skiers are captured on Saddle Peak. And just showing what we can do with time-lapse photography with that avalanche event. And I actually was working on my camera that day, so shortly after the avalanche happened, I went up to the gun platform where Doug Richmond of Bridger Bowl Ski Patrol was coordinating the response. And we pulled out the camera, we took a look, and we actually were able to identify the skiers who triggered the avalanche, see them trigger it, come back inbounds, and note that they were okay. So we were able to assist in the response. In that Bridger Bowl didn't have to put a whole bunch of people on the slope. We kind of had an idea of people involved. So along with the research implications that I can get out of what I'm finding on Saddle Peak, there's also a potential to use this technology in rescue response and maybe high use areas adjacent to ski areas or that high use area on the pass somewhere in the backcountry. So there's a lot of different ways we can use this. Thanks for listening, and can I answer any questions?